So this lecture we're going to talk about rational expressions and reducing to lowest terms. So generally the technique when you have to reduce quotients is to factor as much as possible and then reduce. So let's start with this example here and factor the numerator and denominator as much as we can. So looking at the numerator, we have a common factor of what? Well, this term has 12x and then minus 9y. So we're not going to be able to factor out an x or a y, but we can factor out something in common with these coefficients, which looks like a 3. So we could factor out 3, and we'd be left with 4x minus 3y. Right? So factoring a 3 out of the 12 and the minus 9, we would get this. What about the denominator? So we have 3x squared plus 3xy. So we can factor out a 3x, and we would be left with an x plus, and if we factor 3x out of 3x squared, we're left with an x. If we factor 3x out of 3xy, we are left with a y. And at this point, we can reduce. So how do we reduce? Well, we reduce out any common factor. So this 3 and this 3 will cancel or reduce, and we have our solution, which is just 4x minus 3y divided by x times x plus y. Our next example, let's see how much we can factor and reduce here. So we have a squared minus 4a minus 12. So factoring the numerator, we have this leading coefficient of 1. So we just need to determine what we're going to add or subtract here. So we have a minus 12, so one of them is going to have to be positive and one will be negative to give us a product of minus 12. And which factors will give us a sum is negative 4. So factors are 1 and 12, 2 and 6, 3 and 4. And the ones that are distance 4 apart are 6 and 2. So 6 times 2 will give us 12. But if I want to have a minus 4, then I'm going to have to give the minus to the 6, so that when we add the 2 to that, it will give us the minus 4. And you can check this, right? So the product of these two is minus 12, and the sum of these two is minus 4, so that is the correct factorization. And what about down here? So still leading coefficient of 1, so we have a and a. Product must be positive 12, and we are going to have a positive 8. So right away we can tell that these are both going to be positive. And which factors of 12 will sum to 8? Well, now this is actually still going to be 2 and 6, but we're positive, right? So the product is 12 and the sum is 8, so that looks like the correct factorization. So now we can reduce if possible. And looking at this, do we have any common factors among the numerator and denominator? And the answer is yes. We have this a plus 2. So this a plus 2 will reduce, and we are left with the remaining fraction a minus 6 over a plus 6, and that is our answer. Moving on, so now we have 20y squared minus 45 divided by 10y squared minus 5y minus 15. So the numerator, factoring as much as we can out of this numerator. Are there any constants in common amongst these? Looks like the greatest common factor would be a 5. So what would be left over? 4y squared and then a minus 9, right? Now, if you are ever concerned that you didn't factor out the greatest common factor, then there would be some factors left over. But 4 and 9 don't have any common factors to factor out any further, so we can't factor out any more constants. However, we will be able to actually factor this a little bit more. Okay, so let's leave that alone for just a second. We'll be able to factor that a little bit more because this is this has this y squared term, and it looks like we have a difference of squares, so we'll be able to factor that. And down here, can we factor out a constant to begin with? So we have a greatest common factor of 5 here. we're left with a 2y squared minus just the y, and then minus 3. And then now we're going to proceed by factoring what's left over. We definitely reduce these 5's, right? But we have some things left over that we can factor. And if we remember, we had something that we can do when we have squares, right? So 9 is 3 squared, and this right here is what? So let me take out this color here. So this is actually 2y squared, and this is 3 squared. So we have a difference of squares, and if you remember, that allows us to factor this a little bit more. And what do we get? Well, we will get 2y minus 3, and then 2y plus 3. Okay, and that will result in no middle terms, and we will have definitely the first gives us the 4y squared, and the last gives us the minus 9. And what about what is left over down here? Now we can factor what's left over in the denominator by a trial and error method, right? So we are going to have a 2y squared as the leading term, so we're going to have a 2y and a y. The product of the last two terms is going to be negative 3, so the only factors that are possible here are 3 and a 1. We just have to figure out which one is the negative and which one is the positive. Well, if I were going to have a sum of negative y, then it seems like I'm going to have this as the negative 3, and this is the positive 1. And we could just check that real quick, because the 2y times the 1 will be 2y, and then the negative 3 times y will be negative 3y, and when we sum those, we'll get negative y. And indeed, leading term is fine, and the last product is negative 3. So do we have anything in common? Well, we have the 2y minus 3 in common, so that's going to reduce, and we are left with 2y plus 3 divided by y plus 1, and that looks like our solution. Moving on to our next example, we have 12y minus 2xy minus 2x squared y. So what can we factor out here? Well, we can definitely factor out a 2. So we have a 6y minus xy minus x squared y. And the denominator, can we factor out anything here? Well, we can factor out a 2 as well. And we would be left with 3y minus 2xy minus x squared y. And then we can reduce and factor what we have left over. So the 6y minus xy minus x squared y, we can proceed to factor what we have here. So what's the strategy that we can use? Well, first, do you notice, do we have any other common factors here? So some strategy is to just factor out that constant, but we also have this common factor of a y. So let's factor that out as well. So we have a y, and then we're left with 6 minus x squared. And in the denominator, we also have that common factor of y. So we would be left with 3 minus 2x minus x squared. Okay, so sometimes you might not notice that initially, and you could factor, if you do notice it, then factor out everything that's in common, which I should have done, but it's good to see that you could do this systematically if you need to. And then we can proceed to factor what is left over. So we can factor the 6 minus x squared as one of these is, since I'm getting minus x squared, one of these is going to have to be a minus, and one is going to have to be a plus. So plus x and minus x. And how do we get what is here? Well, the factors of 6 are 1, 6, and 2, 3. And which of those are distance 1 apart? Well, that's going to be the 2 and the 3. So if I want to have a negative, then I'm going to have to put the negative with the 3 and the positive with the 2, right? So now 3 times 2 is 6. What are the middle terms? Well, negative 3x and 2x, and the sum of those is negative x, and the last is negative x squared. So that looks like it's correct. And what about down here? Well, again, if we're going to get a negative x squared, one of them is going to be positive, one of them is going to be negative. And the factors of 3 are only 1 and 3. So now we just have to figure out where the 1 and the 3 go. Well, now I'm getting minus 2. So the negative needs to go with the larger, the 3, and the 1 will be here. And let's double check that that's right. 3 times 1 is 3. And then 3 times negative x is negative 3x, plus x gives us negative 2x, and then finally negative x squared. And then do we have any common factors? Yes, the 3 plus x. That reduces, and we are left with our answer, 2 minus x over 1 minus x. And that's as far as this reduces. Our next example, let's just jump right in. So 42, 23 minus 10. What are some common factors here? Well, unfortunately, 23 is prime. So the only choice would be to either factor 1 out, that's not going to do anything, or 23, but that's not going to go evenly into these givens here. And what about what's down here? Well, 14 is 2 times 7 and 45. That doesn't have any common factors to that because that's 5 times 9, and so that's 5 times 3 squared. That doesn't have any common factors either. So we're just going to have to trial and error figure out what this factorization is, right? So the numerator factors into what? Well, by some trial and error, we can slowly determine some possibilities, right? Looking at the factors of 42 and 10, right? So 42, we have 1 and 42, 2 and 21, 3 and 14, 6 and 7. And then with 10, we'd have 1 and 10 and 5 and 2. And we could slowly do some trial and error here. But we would get a 6x plus 5 and a 7x minus 2 for the numerator. And what about the denominator? With a similar strategy, we can do some trial and error, but there's going to be a lot less possibilities because the factors for 14 are 2 and 7. So the only possibilities for this would be 14 and 1 and 7 and 2. Same thing for the product in the on the end. But so by trial and error, we would get the 2x plus 7 and 7x minus 2. And if we're going to get some reduction, you should expect probably one of the possible factors is going to be involved here. And it is the 7x minus 2 is the one that gets reduced. And we are left with 6x plus 5 divided by 2x plus 7. For our next example, we have a squared minus b squared. So a difference of squares, we know that that factors as a plus b, a minus b. And on the denominator, we have a difference of cubes. And we also had that as a special product, which factors, right? So difference of cubes, the special product that it factors into would be the a minus b times the trinomial a squared plus ab plus b squared. And now we see that we have this common factor of a minus b, which reduces, and we're left with a plus b over a squared plus ab plus b squared. Continuing on, if we look at this one, how are we going to factor this? Well, this one is already split up. And so what we could do is we can try factor by grouping. You see that we could consider factoring these two, like this binomial and this binomial, separately from one another. So what would that look like? So let's try to factor that binomial and this binomial separately. So we can factor out of this first one it looks like we could factor out x. So then we'd be left with x minus 3a. And over here, what can we factor out? Well, we could factor out we could factor out just the 2, right? Now, if we factor out only the 2, what are we left with? We're left with minus x, and then we were left with plus 3a, okay? However, do you notice that when you're doing factor by grouping, you actually want the leftover terms to be the same. And you see that they're actually negatives of one another? So what we're going to do instead is we're actually going to factor out a negative 2. Okay, so what happens if we factor out negative 2 instead? Okay, if we factor out negative 2, then we are left with just an x. And if we factor out negative 2, then that makes us a negative 3a. And now, this is good, because once we factored out our greatest common factor amongst those two binomials, then what's left over is a common factor. Okay, so we'll get back to that. So I wanted to show you sort of the wrong factorization and then look at it and see how we can fix it. Okay, so let's see what happens if we factor these two binomials. So what's the most that we could factor out of these two? Well, we could factor out an x, and we are left with x minus 3a. And over here we can factor out a 2, and we're left with x minus 3a. And this is good because what's left over is something in common. So how does the factorization work now? Well, what can we factor out of these two? So let me switch this to red. So what can we factor out of this and this? Well, they have in common the x minus 3a, so we can factor that out, right? So we can factor out x minus 3a, and we can multiply what's left over. And what's left over, well, if we factor this out of the first term, then we're left with an x, and if we factor out x minus 3a out of the second one, we're left with the minus 2. What about the denominator? Well, similarly, we have this common factor of x minus 3a, so we can factor that out. Let me switch to a red here, and we will factor out x minus 3a as well. And what will we have left over? Well, factoring that out of this first term, we're left with an x. Factoring this out of the second one, we are left with a plus 2. And now we can see that we have this common factor of x minus 3a in the numerator and denominator, which reduces, and we just have x minus 2 over x plus 2. And that is what we get. Moving on, our next example, we have a cubic, and it is not a cubic that is a difference of cubes, and we don't have a common factor of x amongst all these. So when you encounter a cubic like this, chances are I'm not going to give you something super crazy, so a factor by grouping method should work if it's not one of the special cubes. So let's try to do a factor by grouping. So factor as much as you can out of the two separated binomials, and what do we have? Well, out of the x cubed and the plus 5x squared, I could factor out an x squared, and I'd be left with an x plus 5. And over here, we could factor out a minus 4, it looks like, right? So factor out a minus 4, and we are left with x out of this, right? And a plus 5, which is great, because we have this common factor of x plus 5 that we'll be able to further reduce. Now, what about the bottom? The bottom is a quadratic. Leading coefficient is a 1, so we're going to have x plus something, x plus something. Well, what do we have? We have positive 10 and positive 7. So we want the product to be positive 10 and the sum to be a 7. And those two factors would be 5 and 2. Right? The product is 10. Their sum is 7. So that looks good. We can now further factor, and we have x plus 5 times what's left over, x squared. Right? I'm factoring this out of this whole term, and I'm left with an x squared. Factor x plus 5 out of this, and we are left with a minus 4. And x plus 5, x plus 2. And so far, it looks like the x plus 5's reduce. And we have left over x minus x squared minus 4 and x plus 2. But are we done? Well, we're done as long as we can't factor anything further. But what do we have here? We have a difference of squares, and that can be factored a little bit more. This can be factored as x plus 2, x minus 2, right? Difference of squares. And then we still have in the denominator the x plus 2, so we actually get a little bit further reduction, and it looks much better. So we actually have just x minus 2 in the end. Now going on to our next example, we have in the numerator a difference of squares. So what are those squares? Can you identify them? Well, this is 5y squared, and the 4 is just 2 squared. So the numerator will factor as 5y plus 2, and then 5y minus 2, just as we saw when we were dealing with these special products and factorizations, right? So difference of squares factored like this. What do we have in the denominator, though? Denominator, we have 125y cubed plus 8. So that looks like a sum of cubes. So what is this? Can you write this as a cube? Well, that would actually be 5y cubed, right? 5y cubed. 5 cubed, 5 times 5 is 25, like we had up here, but then multiply that by 5 and we'll have 125. So 5y cubed, and 8 is 2 cubed. And if you look back at our notes for the sum and difference of 2 cubes, when you have the sum of cubes, then we know how to, so recall the following formula. So if we have the sum of 2 cubes, this factors as a plus b, and then times the trinomial a squared minus ab plus b squared. So that's the sum of 2 cubes. So in our situation here, a is what? A is this 5y. So here, and what's b? B is 2. So all we got to do is just replace all the a's with this 5y, and the b's, let me switch to another color here. The b's will replace with a bunch of 2's. All right, so that's how we will use that formula. So let's write that out. So we will have a plus b, so that'll be 5y plus 2. 5y plus 2. Hey, look at that. That's going to be a common reduction. But what do we have over here? So we will have 5y squared minus 5y times b, which was 2, and then plus 2 squared. And let's simplify that. Well, the 5y plus 2's reduce. And what do we have left over? We have the 5y minus 2 in the numerator. And then down here we can simplify this a little bit. This is 25y squared minus 10y, and then plus 4. And this will be our answer. All right. There's no way to further reduce this, okay? Otherwise, I would have given that to you over here as part of the general formula. For this next example, I just want to show you how you can manipulate things a little bit with negatives. So notice that I have 6 minus x divided by x minus 6. So these are very similar, the numerator and denominator, except they differ by a negative. So what happens if I factor a negative out of the numerator? If I factor a negative, then I get negative 6, right? And then I will get plus x. Denominator stays the same, x minus 6. And then look at what we have up here. Negative 6 plus x is the same as x minus 6. And then x minus 6, well, now I can reduce. And what do you have left over? Well, you're not just going to have a negative. That doesn't make any sense. But up here, the numerator always has, a factor of 1, and the denominator has a factor of 1. So I have left over negative 1 over 1, which is just negative 1. So that would be the reduction here. Similarly, for our next example, we can do something very similar. So let's see what we get. We can write that the numerator is 1 minus y. That's sort of already factored. But down here, difference of squares, that's y plus 1, y minus 1. All right, and now if we want to reduce, it looks like these two factors are very similar, right? 1 minus y, y minus 1. So can we factor a negative out of the numerator? If I factor that out, then we are left with a negative 1 and a plus y. Denominator stays the same. But then negative 1 plus y is the same as y minus 1. So this is negative y minus 1 over y plus 1, y minus 1. And these reduce, and we are left with negative 1 divided by y plus 1.